Last section, natural logarithms. Okay, so in 7.2 we talked about e, this natural log, e, which is a number that goes on forever, for continuous rate. Now the inverse, so the opposite, is called the natural log. So we have a log, base e, that would be the natural log, or it's written with just an ln. So these two things are the exact same. Log base e is the same thing as natural log. So normally when you just see a log of x equals y, my base here would be 10. If I see a natural log of x equals y, my base is e. So natural log, inverse of e. So this would be if I were to graph the two functions. Now everything that we do with log is the exact same properties as natural log and solving. So these first two, if I'm going to write as a single log, those three properties we have are the exact same. So if I have a 2 on the outside, I can write that as an exponent. And if I see subtraction, that's going to be division. So first I write natural log, I see subtraction, write division, 15 squared over 75. So if you simplify that, it's natural log of 3. So again, when I'm looking at b, I see addition, so that would be multiplying. If it's multiplying on the outside, that becomes an exponent. So break natural log only one time. I have 7 times 5 squared. Now this is pre-algebra, remembering you have to do 5 squared before you multiply by 7. So it'd be 25 times 7. And I get natural log, natural log of 175. Try those other two by yourself. So now I'm actually going to start solving for these equations. Now just like with log, you want to rewrite a log as an exponential function. So in this case, my log base is e. So I can rewrite this as, remember, it's whatever the base is, raised to the exponent is equal to this. So I have e raised to the 4th power is equal to x minus 3 squared. I want to get that x by itself, so the first thing I want to do is take the square root. So now I have e raised to the 2nd power. How did I get that? Remember, the square root is like a 1/2. The other part that you can't forget here, taking the square root, remember, when you have something squared, there's actually 2 numbers that works here, because this will make everything even. So this should have a plus or minus, and that will be equal to x minus 3. So I want to solve for x. I'm going to add over my 3. And I get 3 plus or minus e squared would be equal to x. So you want to split this up into your calculator. So you do 3 plus e squared, and you do 3 subtract e squared. And your two answers be 10.3891 and negative 4.3891. There you go. Second one. When I'm looking at this, my base here again is e, so I'm going to rewrite it. So it's e squared is equal to x. Then I just put e squared into my calculator, and that's actually all I have to do for that one. So it would be 7.3891. So I want you to try to do c and d by yourself. D, you have to be careful, because you want to rewrite this as one single log first before you rewrite your exponent. So now the flip-flop, the flippity-flop-flop, the flippity-flop-flop, the flip-flop. So the inverse is what I'm saying with the flip-flop. I'm going to subtract my 2. I'm going to get my e by itself first. So subtract my 2. E to the 2x is equal to 14 divided by 4, so it's going to be a fraction. It's equal to, if I divide this by 4, they're both divisible by 2, so it's going to be 7 halves. Now, I'm going to do the natural log on both sides. Move this over a little bit. Natural log over here, natural log over here. The reason why we do that, remember, is that there's a base e here. So base e natural log with base e exponential will cancel each other out. Wham, bam, thank you, man. Leaving you with just the 2x is equal to the natural log of 7 halves. And now I'm going to divide this whole thing by 2. So x would be equal to this in your calculator. So in your calculator, natural log of 7 divided by 2, close your parenthesis, and then divide by 2. You have to make sure to close that parenthesis, and that would be equal to 0.6264. Next one, my e's already by itself, so I'm going to do my natural log on one side, my natural log on the other side. So if I were to write it out, it looks like this. Natural log 12. And these two cancel, leaving you with just the x minus 2 is equal to the natural log of 12. And then you add 2. Be careful, this is the only thing you're taking the natural log of. So in your calculator, natural log of 12, and then close your parenthesis, plus 2. So x equal to 4.4849. Try to do C and D by yourself. So I'm not going to lie, when I see something like this, I get a little overwhelmed. It's like so much reading. But one thing before I actually start reading this, I see an equation. So right away, I'm going to write down V equals negative 0.0098t plus C ln r. And then I'm going to go through to see if I have anything that's actually given to me. Spacecraft contain a stable orbit of 300 kilometers. Earth reaches its velocity at 7.7 kilometers seconds. To calculate the velocity in kilometers per second is that equation. The booster rocket fires after t seconds. The velocity of the exhaust is c. The ratio of the mass can be filled with fuel, and the mass with the fuel is r. So suppose the rocket in the shown mass ratio is 25. So that just said that was the r is 25. Bam. A firing time of 100 seconds. That was our t. T equals 100. And exhaust velocity is shown. So c, that was our c, is equal to 2.8 because that was in the picture. And basically, can the spacecraft attain a stable orbit? So we're going to plug in all that stuff that we know. So we know V is equal to negative 0.0098. For T we have 100. For C we have 0.28. And for R we have 25. Plug that in your calculator. Beep, beep, boop, boop, beep, beep, boop, 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 boop. That's about 8.0. That was our velocity, kilometers per second. So if we go back and reread this again, it says it reaches a velocity of 7.7. So yes, 8 is greater than 7.7. So since that is greater, then yes, it would be able to create a stable orbit. There you go. Have a great, grand, wonderful day.